So, good morning, everybody, and thank you for attending our session. This is the session about IIS, new scalability and manageability features. My name is Erez Ben-Ari. I am the PM for IIS with Microsoft. I've been with the company since the year 2000, and before dealing with IIS, I was part of the Forefront family products named UEG and TeamG. You might have heard about them. With me today is my colleague, Ahmed Al-Sayed. He's from our test team, his software development engineer and test. He's been with the team since the year 2011. Before we start talking about IIS, I just want to mention our platform in just a brief few words. We have multiple cloud offerings in that realm. We have websites for Windows Server, which is a hosted or private cloud, and we have the Windows Azure websites. Both these offerings are part of my team, and all of these run, of course, on IIS, which is still going strong with Windows Server. We are having a new version coming out with Windows Server 2012 R2. And what's new about it is that, first of all, it's version 8.5. And we have some new features that focus on scalability and manageability. The new features in brief are dynamic site activation, idle worker process page out. We have some logging enhancement and ETW logging. And now switching over to Ahmed to talk about the features.
Okay, good morning, everyone. So basically for our 2012 R2 release, as Erez said, one of the main areas we wanted to focus on is scalability for IIS. And what I mean by scalability is basically doing more, configuring more sites, running more sites, doing more SSL, doing more certificates, this kind of things. And as you all know, in the 2012 release, we already did a lot of work on the SSL and Central Search Store and SNI for IIS that allows you to scale to a much larger number of sites that are doing secure SSL. However, for the R2 release, we listened to some of the feedback we heard from our customers, specifically our hosting provider customers, about how many sites they can configure in a single IIS machine. And that was this feature, dynamic site activation addresses. So what we found from our hosting customers is that they are config bound. And the reason they are config bound is because when you have a very large number of sites configured in IIS, you run into issues dealing with resources, mostly memory. And so we decided to take a closer look on this issue and this problem in R2. And we found two main parts to this issue. The first one is config itself and the memory it consumes. And the second part is the HTTP registrations and the memory it consumes, the kernel memory that consumes. So to address the two issues, I'm going to first address the config issue and tell you what we did there, and then talk about the HTTP registrations. So for config, as you know, when you start IIS, the Windows Process Activation Service, or WAS, starts up. And WAS loads the entire config for IIS. Now, until now, WAS was using the same config object to load config as, say, the worker process. That config object is called native reader. Now, native reader was designed, and it's very efficient, and it's very fast for loading small configs, which is the case for a worker process. When you start a site, that config for a single site is very small. So we designed config reader to be extremely fast in loading that config, because the first thing a worker process would need to do when it starts up is basically reading the config. So we didn't want to stop the worker process or delay it by doing any more work. So we designed the native reader to be extremely fast for this case. However, native reader doesn't scale very well for extremely large configs. And if you're going to have 4,000 or 5,000 sites, which is the number hosters usually run into a problem with, you're going to start having issues with memory usage in native reader. So to solve this issue, we decided to create a completely new config module for WAS. We designed this new config module. It's called AppHost Config Provider. And the AppHost Config Provider is basically very optimized for WAS-specific need. So when WAS loads the config, it's not looking for modules. It's not looking for handlers or custom error pages. It's only looking for a list of the sites, their bindings, the application pools, and the application pool settings. That's all WAS really needs to know at startup. So we designed this config module to basically load these 5 things. It doesn't need to know about everything in the module. It just needs to know about these 5 things. And what this gives us is huge scalability and huge improvement in the amount of memory used by WAS. So this is the first part of the issue, which is config. And we solved it by creating a new config system for WAS that's more efficient in dealing with larger configs. So the second issue, as I said, is HTTP registrations. When you start IIS and WAS starts up, it looks something like this. You have your WAS service running, and it goes and reads config, assuming it's using the new, improved, optimized config reader. It still needs to go and register every site and every binding with HTTP. So you have here, as you see, these queues and bindings registered with HTTP at startup. So if you have 5,000 sites, you're going to end up with 5,000 objects of these in the memory. So, and the reason this was happening is because when a request comes in, say in this case for site number 3, HTTP sys needs to know where to route this request to. So in this case, it's going to route the request to the queue number 3, and WAS is going to get notified that there's a request there. It's going to start the worker process, and the worker process is going to process the request and sends the response back. So this is the way it was always done in IIS since IIS 7, IIS 8. However, for the R2 release, but this doesn't scale very well, as you can see. So for the R2 release, we decided to take a look at this. And what we did is basically give WAS the ability to open a request and look inside of it. And what this allows us to do is something like this. Now, when WAS starts up, it doesn't need to create thousands of queues for every site and thousands of bindings. It only creates one queue and one binding. It's sort of a catch-all binding, as you can see. In this case, it's a start 80 binding, so it's catching anything that's sent on port 80. So how will this work when you send a request? It will work something like this. So the request here is, again, for site number 3. It's going to go to HTTP sys. HTTP sys only sees one queue, so it's going to route it to this queue. At this time, WAS is going to open the request and take a look inside of it. It's going to find that it's for site number 3. It's going to go to the optimized list that I spoke about and look, does it have a site number 3 in it? And yes, it does. So it will go and create a queue for it at this point. And after the queue is created and the binding is registered, it's going to ask HTTP, please reprocess this request. So HTTP is going to take the request, and it starts all over again. But this time, it's going to find a queue for it. So it's going to put the request in the queue. WAS is going to get notified again and starts the worker process, and everything should continue to work the same it did. So as you can see, these are the two issues we had, the config and the HTTP registrations, and this is how we fixed them. The config, we created a new optimized version, optimized module for the config. And for HTTP registrations, we totally removed the linear dependency between the number of sites and number of bindings with the number of created objects in kernel. So what does this feature actually look like? Well, this feature doesn't have a UI, because as you can see, it doesn't really require one. Everything that happens should be completely transparent to any user or any IIS admin. Everything is done between WAS and between HTTP sys. However, we added a new threshold value, and the default is 100 sites. Anything below 100 sites, if your machine has anything below 100 sites, it's going to continue using the old mode. If it has any more than 100 sites, it's going to use the new mode. And the reason we did that is because, as I said, native reader is extremely fast and extremely efficient with small config. So we figured anything less than 100 is going to be small enough for native reader to give you the benefit of being extremely fast. Anything larger than 100, you would want to use the new mode to get the benefits of scaling to a very large number of sites. So now I have a demo for you to show how this actually works and looks like. So here I have two machines, a 2012 machine and a 2012 R2 machine. First, let's take a look at the request queues and the bindings in HTTP. This machine, as you can see here, is configured with 10 sites and 10 application pools. So if I open this, here you have 10 sites, and here you have 10 application pools. So to take a look at the HTTP bindings, I do netsh http show service state. OK, did you catch that? OK, let me pipe it to something, and we can look at it page by page. So here you have URL groups, which is the HTTP sys notation of bindings. So for example, here you have a binding for site number 5. Here you have, again, binding for site number 8, 3, and so on. You're going to have 10 of these for this machine. After these are done, this is a binding for remoting service, which is not IIS. Now you have request queues. You have a request queue number for site number 5 here. You have a request queue defined for site number 8, and so on. So this is what it looks like in IIS 8 right now. However, for the R2 release, again, the machine is also configured with 10 sites, as you can see here. 10 sites and 10 application pools. So let's run the same command and see how it looks like. It is http show service state. Sorry. Again, let's pipe it something. So this is the remoting service we're not interested in. And now we have a binding again for site 1, and a binding for site 4, and so on. Site 3, we have 10 bindings. And if we're done with this, we have also 10 request queues. So it looks exactly the same. And that's because, if you remember, I said that the threshold is 100. So let's go and change that threshold and see what happens there. The way you change that is using config editor. You go into the system application. You go into the system application and then whip limits. And when you go there, you're going to have this new option called dynamic registration threshold, and the default is 100. So let's change it for something that's less than 10, for example, 1. Hit apply, and now let's restart WAS. Because when WAS starts in one mode, it doesn't change during runtime. You have to restart it. So do let's stop WAS, and let's start the 3SVC. So this is going to restart WAS, and it should start in the new mode. And we'll take a look at the HTTP service state at this time. So let's use the same command we used, which is this one. So the first URL group, which is the remoting one we're not interested in. And now here, see, now we have this binding, and we're done. We don't have any more bindings. There's only one binding for start 80. And if we look at the queues, we have only one queue here, which is this one. And it's called W3SVC inspection. And this is the queue WAS uses to queue the request that it's going to look at and figure out if it has the site or not. So what happens now when I hit a site? Say I'm going to hit site 1. So site 1 loaded. And when I go now and take a look at the queues and the bindings, I'm going to see this new URL group for site 1. And the binding is created. And I have a queue here for site 1. And if the process goes away for this site, WAS is going to take care of cleaning this queue up. OK, so this is for HTTP status. So how about memory consumption? Let's do an experiment here and try different configs with different number of sites and see how much memory we consume in the old mode and in the new mode. So let me start PowerShell here. And this is the 2012 machine. Let's go to my demo folder. And here I have a script called swap config. And all that script does is basically I have a bunch of pre-created config files with different number of sites. I copy that config file to the application host, the config location, instead of having you wait here while I create thousands of sites. OK, so let's start by 10,000. And the reason I'm going to start by 10,000, even though we hear from our customer that they usually run 5,000, is because these are shell sites. They don't really have config. They are empty. Once you add more location tags and more special config for every site, the config is going to grow larger. So I figured 10,000 is fair to start with. So let's start by 10,000. So 10. So this script stops WAS first and then replaces config. And it gets back to me. Now I have another script here, which called measure time and memory used. And all this script does is starts W3SVC. It measures how long it takes in milliseconds. It gets the WAS process ID, and it uses that process ID to get the private memory for that process, and then it gets it in megabytes, and then displays the result. So let's launch WAS and see how long it takes and how much memory it consumes. This is the 2012 machine again. So it's done. It took about 6.7 seconds. And it consumed 329 megabytes. So, OK, that's not too bad. Let's take a look at the R2 machine. Again, let's start PowerShell. and go to the demo folder. Let's use the same script, swap 10,000. Gonna swap config here. And let's measure how much it takes. So as I said, native reader is a bit faster for smaller configs, so native reader is going to be faster, and it's done. So here it took 7.1 seconds. The other one took 6.7, which is very slightly faster. However, it took only 163 megabytes of memory, while this one took 329. And if this is not impressive enough, actually this memory, since the new config provider is managed, there is a bunch of memory that we clean up. However, the GC doesn't run. It doesn't run on demand, so it's going to be cleaned up in the next GC run. And if you want to take a look at this memory, what you have to do is basically go to the CLR memory, and then the SVC host is the WAS process. So I'm going to take a look at the managed memory here. And basically, if you see this Gen 2 memory, this memory is going to be cleaned up on the next GC run, basically. So here you have about 45 megabytes or 45 megabytes of memory that's going to be cleaned up on the next run for the GC. Subtract that from 163, and then compare that to the 329. So okay, so this is with 10,000 sites. Let's try something bigger. Let's try 50,000. So this is the 2012 machine. I'm starting WAS and replacing config. And now I'm going to start measuring. And while this is running, because this is going to take a while here, let's do the same on this machine. This is the R2 machine. So let's first close this thing. And let's swap config with 50,000. And now let's start measuring the memory used. So this machine is still running. This one also is still running. This usually takes about 23 seconds on this machine. From previous runs I tried. We can peek at the memory here using Task Manager. So as you can see, it's okay, it's done. And in the 2012 machine, it took 49 seconds, and it consumed 1.6 gigabytes. And everything here is native, so there's no memory that's going to be cleared up on the next GC run. On the R2 machine, it took 22 seconds, which is compared to the 49 here, and it consumed only 700 megabytes. And there's also a big chunk of that that's going to be cleared up on the next GC run. So okay, so it's still working in both machines. Let's try to push it a bit more. So let's try with 100,000 sites and see what will happen. So 100,000, I'm going to stop WAS. And I want you to notice something here. See on the 2012 machine how long it just takes to stop WAS? It's going to be spinning for a while here. And the reason is because of all the registrations we did with HTTP. Now we have to go and clean them up one by one. While if I do the same thing in the R2 machine, if I do the same thing, let's swap with 100. Because we only have one binding and one queue, we're going to see WAS stops instantaneously. So WAS here stopped, while WAS here is still trying to, OK, it's done here. So let's measure the memory on this machine. And let's measure it here as well for 100,000 sites now. So they're going to start running. This particular config takes about a minute to load on the R2 machine. I'm not even going to wait for the 2012 machine, but we'll see. Let's also peek at the memory consumption here. So it's up to 2 gigabytes now on the R2 on the 2012 machine. Actually 3 now. Well, so as I said, the default threshold is 100 sites. So if you have less than 100 sites, it's not going to make a big difference in memory, and we still want to give you the benefits of native reader being very fast in loading config. If you have anything more than 100 sites, it's where you're going to start seeing benefits using this. So you can also configure the threshold to whatever value you want, but we figured that 100 is a good number for to get the benefits of both. It depends on your load, of course, but. Well, we had the other option. We had to keep the other option for backward compatibility with other stuff we already had. And also, since, as I said, native reader is faster with smaller configs, we figured we would give you that benefit of using native reader with smaller config. So you have both options here. OK, so the 2012 machine has 6 gigabytes now of memory, while, OK, this one is already done. I consumed 1.1 gigabytes total. And if we look at perfmon, we're going to see also a bunch of memory that's going to be cleared up on the next GC run. Let's take a quick look here for SBC host. So as we can see here, there is a 200 megabytes that's going to be cleared up on the next GC run from this 1.1 gigabytes. And it only took one minute to finish. This one is still running, and it's now up to 6.6 gigabytes. And I'm not going to make you wait until this finishes, because it takes a while. So let's switch back to the presentation. OK. So as you can see, now WAS can scale to a very large number of config sites. This addresses the first scalability issue, which is being config bound and scaling to a very large, and being able to configure a very, very large number of sites on a single machine. However, a second issue that comes up as a side effect of having a lot of sites configured is basically cold requests. A cold request is a request that comes for a process that is not started yet. This request has to wait for IIS initialization time. It has to wait for the application framework initialization time. That's .NET or PHP or Python or whatever, or what have you. It has also to wait for the site-specific initialization time. So the performance for these requests is not great. And we heard a lot of feedback from our hosting provider customers who host a lot of dense IIS machines that customers that have infrequently hit sites are not very happy about this. So we wanted to address this issue and see if we can improve anything. We already know that we did a lot of work in IS 8 in the 2012 release that will improve this behavior. So we wanted to see where we are at with the 2012 release, and then continue to work to see if we can improve things more. So to see where we are at in the 2012 machine, 2012 release, we created this experiment in our lab. We tried to contact our hosting customers and to get an idea on how they use IIS. We built this simulation in our lab to simulate how the hosting providers use IIS. We had a cluster hosting 4 IIS machines. We had a NAS, a network storage that has the config and the content for all the sites. We had other clusters hitting the same NAS to make sure that it's hot enough to simulate production. And then we measured cold start times, the time it takes to start a new site, from one of the IIS machines. And the times we measured, we were measuring from the client perspective, not from the server perspective. So what our configuration looked like, we had 4,000 sites, which is, as I said, around the high-end number you would find these days in IIS. For runtime, we made sure we have 500 sites running. And with 2 sites starting up and 2 sites coming down at any given time, to simulate a real-world scenario where sites come up and go down all the time. And this also induces work in WAS to create config for the new sites and to clean up config for the old sites. So we wanted to make sure that we simulate a real-world scenario. We also had the NAS. The NAS was hit from 7 different machines to make sure that we have enough load on the NAS. So this is the configuration and the experiment we did. And what did we find out? So these graphs show you the difference in static files from IS 7, or 7.5 in this case, and IS 8 for the 2012 release. And as you can see, right off the bat, there is a huge improvement in IS 8 compared to IS 7.5. Especially around the 500 mark, when we actually start killing processes and bringing up new processes. As you can see, the IS-8 both start up at around the same time, which is 300 or 400 milliseconds. While IS-7 gets progressively worse as you move on, IS-8 maintains a steady performance throughout the experiment. And as you can see, this is 400 milliseconds, which is less than half a second for IIS to start a new worker process, to have it fetch the config from a remote machine, from a remote network share, and fetch the content and deliver it to the client. And these times are measured from the client perspective. So it takes IS-8 400 milliseconds to start a process and get it ready. So what's the issue? Why are people complaining? Well, this is a static IIS process. This doesn't have any managed code in it. So let's look at some dynamic numbers. So this is a dynamic numbers for a dynamic site, in this case PHP. And as you can see, similar pattern between IS-7 and IS-8. IS-7 getting progressively worse, especially after the 500 mark. And while IS-8 is maintaining a steady performance. However, these are the numbers we're talking about. So these are the 4,000 milliseconds or 4 seconds to get a response back, or it might actually be 5 seconds. So in this case, a customer has, or a client hits the server or hits the site, has to wait for 5 seconds to get a response back. While this might not sound a lot, it's actually a large time for a client to hit a site and wait for the site to start loading. So we wanted to profile these requests to better understand where is time spent. Are we doing anything wrong for dynamic content specifically? And now let me actually show you how we do this, how we profile requests, and how can you also profile requests on your machine to better understand how to do this. So what I have here is a machine. I'm going to go into my demo folder. So the way we profile requests, we use ETW logs. ETW events, sorry. Every component in Windows throws ETW events. And you can listen to any ETW event you want using Logman, which ships with Windows. So here I have a script called create trace. What this script does is basically it uses Logman to create a trace. In this case, the trace is called request. And this is the buffer size for the trace and the number of buffers. I'm having the output written to the C drive with a prefix request. I'll be listening to the HTTP provider, the IIS provider, and the ASP.NET provider. So let's clear this and let's create the trace. So now the trace is created. This machine has 200 sites configured with Deskblog in this case, which is a popular open source site for hosting blogs. And I have 200 sites. I'm going to send a request to a site from the second 100, and I'm going to tell you why in a while. So here, I'm using wfetch to do this. And the reason I'm using wfetch and I'm not using IE is because a real browser wouldn't actually just send one request to the site. It's going to send a request to the site, and it's going to try to build a page. It's going to request all the CSS scripts and JavaScripts, the images, and everything to build the page. But I want to profile just one request. wfetch is a tool that we ship, allows you to send one request and control the headers and everything to do what you want, what you really want. So before I send a request, let me start logman start request. This is going to start the trace. So now logman is listening for any events anyone is throwing. And now I'm going to send a request. And this request is going to take a while to respond back. So this is the time people are talking about. OK, so it came back. I'm going to stop logman, stop requests. And if I go to the C drive, I'm going to have here this file, which called request.1_1. So let me open this request. I'm going to open it in the Windows Performance Analyzer, which is also a tool that Microsoft ships that helps you look at ETW logs. And the way this tool works, you're going to see now, the UI looks something like this. Let's zoom in here. So here we have our three providers. We have the HTTP provider at the bottom, we have the IIS provider, and we have the ASP.NET provider. And the reason this doesn't say a name is because ASP.NET provider is a classic provider, and classic providers don't give names here. So what does this mean? Basically, the very first dot here from HTTP is when HTTP receives the request. So it's saying, hey, I have a request, and I want someone to look at. And if you look at more details here, you're going to see that HTTP is saying, for the first one, the highlighted one, it's saying connection established, receive request, parse request. So it received and parsed the request, and now it's ready to actually start to deliver the request to the application, basically. In this case, the application is IIS. So IIS gets the request and processes it, and so this is basically the time IIS takes to start the worker process and have it ready to receive the request from HTTP. So if I zoom in here, as you can see, this time is almost 200 milliseconds. It takes IIS only 200 milliseconds in this case to configure everything. And it's a bit less than the 400 milliseconds you saw before, but this doesn't have any remote network or anything. So here it's 200 milliseconds. So IIS was ready after 200 milliseconds to start receiving the request. After IIS received the request, it notified the application framework. In this case, it's ASP.NET. It notified it that it needs to start loading. And this is the time the application framework took to initialize the site. And in this case, the time is, as you can see here, it's 3 seconds. It took 3 seconds for the application framework to load up and initialize the site. And after it loaded and initialized the site, this might include compilation time. This might include a lot of different initializations and build stuff for ASP.NET. The site took this time to initialize itself and sends a response back, which is 1.29 seconds. And then these are some cleanups that happened in an IIS and ASP.NET post request. So, and if you want to take a look at any of these events and closer look, you can always, for example, here zoom into this event and see. So these are the events IIS is throwing when it first starts, and initializing the pipeline and stuff. And when you look here, you will have the names for these events. So, so this is basically how you can profile a request. Let me switch back to the presentation. As you can see, there isn't really a big room for IIS to improve things. We only take, in this case, it was 200 milliseconds to start the process and be ready. However, the application itself is taking a very long time. So one solution that might come to mind is, why don't you just have the processes running all the time? Just start at one and leave it running forever. And this will solve the cold start issue. And we actually have only the very first request to the site is going to take that time, but then everything is going to work perfectly. And we actually shipped a module or a feature in IIS 8 in the 2012 release called application initialization. All you have to do is set it up for the site. And when you start IIS, we're going to take care of sending a fake request to the site. It's going to take whatever time it takes to initialize and warm up. And then nobody ever has to hit this and see this slow request. However, this is not realistic. And the reason is because of basically optimizing memory usage, or because hosting machines that are running a lot of sites are usually memory bound. And what I mean by memory bound is sites are usually large processes, on average of 100 megabytes if you want to do anything useful. So if you have 100 megabytes process, you can't leave this process running forever because it's going to fill up your server. And you can only have, for example, like 100 sites running while you host thousands. So you need to start killing these processes. And that's why we have something called idle timeout. And when idle timeout is reached, which is by default 20 minutes, we start killing these processes. And it's also why we created a feature in IIS 7.5 called dynamic idle threshold, which you configure it with a memory pressure value, like say 80%. And when the machine reaches 80% of memory pressure, WAS is actually going to take care of halving the idle timeout value for the running worker processes. So if it was 20 minutes, it's going to be 10 minutes now. And if it was 10 minutes, it's going to be 5 minutes. And to be able to kill more processes faster, to bring up newer processes. So since this is the issue, the memory is an issue, so you have to kill processes. and the application time is dominating the cold start time, so there isn't really a room for IIS to improve things. However, we decided to look at the problem from a different point of view. If really the memory is the only issue we have, so why not eliminate this issue? And this is what the idle worker process page out feature focuses on. So basically, instead of terminating the process when it reaches the idle timeout, we added a new option to page out the process. We write the process to disk and empty the memory, and write the process to disk. And now when a request comes in, it's going to generate a page fault. The memory manager is going to take care of loading the page files from the disk to the memory. And if you have a fast disk, like say an SSD, and make your page file on this SSD, this page in process is going to be extremely fast. So, so let's take a look at let's take a look at the demo and see how fast this actually is. And by the way, the UI for this feature is very simple. All you have is a new setting in the app pool section. So if you go and select an application pool and go to the advanced settings, you're going to have now a new option when you reach idle timeout. It's called idle timeout action. And now you have two. It used to always be terminate. Now you can either terminate or suspend. And what we mean by suspend is we're going to page out the worker process to disk. So, let's do an experiment here. This is a 2012 machine. Let's start PowerShell. Let's go to my demo folder. I have here a script. I have a tool here. It's a client that sends requests. And I have a script that's called start. It's called start 100 sites. What this script is going to do is basically send 100 sites, send 100 requests to 100 different sites, and then measure how long that takes. And let me start it here because it's going to take a while. And as you can see, this is not really a real scenario. This is sort of a contrived perf scenario because you don't start your server and you have 100 sites hit at this moment. But we figured it's going to show the big difference between cold starting 100 sites and resuming 100 sites. In this case, there's a lot of CPU contention, and that's happening. And I started Task Manager, I believe. It's going to come up at one point. This usually takes a minute in this machine. These 100 sites are desk block sites, as I said before. The machine is kind of frozen now. Come on. So I'm trying to start Task Manager to take a look at the memory. OK, so it came back, and it took 60 seconds, or 62 seconds. And the memory is almost full. It's 68% now. And if we look at the Details tab, we're going to have 100 sites running. Each one in this case is consuming only 55 megabytes, because we only sent one request to it. OK, so this is the memory it's consuming. And after I configured here the idle timeout to be 1 minute. So after 1 minute, it's going to start killing these processes to basically empty the memory. And once these processes die, if you're going to start them again, it's going to take exactly the same time. So let's take a look at the R2 machine. And this is the machine I used to profile a request. And if you remember, I said let's send request to the next 100. And the reason is I actually have 100 sites running in this machine. And as you can see, the memory, we're not consuming that much memory. It's only 24%. But if you look at the Details tab, there is indeed 100 sites running. But every site is only consuming about 5 megabytes of memory instead of the 55 megabytes. And if I try to, and as you saw, I ran it before. Again, it took 62 seconds in this machine as well. If I try to get processes -name -cwp.count. So I have 101, the one we started for the tracing. So OK, so let's run now the same script and see how long it's going to take IIS to resume these processes and basically bring them back to memory and serve 100 requests to 100 sites. So I hit this, and it's back. So it took 3 seconds. It usually takes 2 seconds in my rehearsals, but so it took 3 seconds here. So as you can see, there's a massive difference, and all the processes are paged in. And as you can see, when they were paged in, they only took 22 megabytes. And that's because the memory manager is only going to page in the pages it needs to serve the request. It's not going to page in the whole process. And basically, this process is going to be there once you configure it to suspend. Instead of killing it, it's going to be there, always suspended, consuming way less memory. And if you have your page file on an SSD disk, it's going to be very fast to resume a process. And if you just hit the process now, say site 3, it's going to come back right away. As compared to here, which I think, yeah, everything has died here. If I go here and hit site 3, it's going to take the loading time for the cold request to start. Come on. Okay.
14 seconds.
Sorry, what? Okay, so the question is, would this invoke the application warm-up feature that came out in 8? It depends on how you configure it. If you configure it to do that, so you can configure your app with both, with the application warm-up and with suspension. So what will happen is, when you start IIS, we're going to send the fake request. The worker process is going to be running, and then after 20 minutes or whatever the idle timeout for the process is, it's going to be suspended, and it's going to be consuming very low amount of memory, and it's going to always be there. So it's warmed up and it's suspended. So you can configure both, yes. Okay, so this was my demo for the idle timeout. And here you have the UI and the Here you have the UI and the presentation if you want to take a look. Okay, so now I'm going to leave you with Erez to talk more about the logging features we did for iOS 8.5.
Thank you, Ahmed. So I'm here to talk about log enhancements. We have made some significant changes to the way logging is performed with Windows Server 2012 R2 and the new version of IIS. The scenario that we're talking about is basically debugging, troubleshooting, and tracking. The challenge here is that there's some data that has to do with servers that just isn't logged and makes it very hard to collect. This is mostly for system administrators, but also in some situations for application developers. We have received a lot of feedback from our customers that want this kind of thing to happen, and it has taken us quite a bit of time to get to it, but we finally made it happen. It just required a certain level of collaboration between various groups within Microsoft to get it to go. The thing about this is that we have environments that have a lot of moving parts. You might be familiar with this, load balancers, web proxies, SSL offloading, multiple routers, and of course, if we're dealing with third-party applications that we don't have control over, that might make it more challenging to work with. The solution we have made up for this is basically defining extra fields to log. So we can now record request headers, response headers, and server variables that come in as part of the requests and log them to disk. We really wanted, customers asked for many specific things, but we wanted something that really is encompassing and can do virtually anything in whatever scenario that you're talking about. For example, let's talk about a situation where you want to collect the client's IP address for the purpose of logging or tracking or finding out a specific user. If you're in a simple environment where you're just having a server that's on the web, that's not a big deal because any client sends his IP address as part of the request. But if you're in a situation where you have a load balancer or a proxy in front of the web server, then what you would see in the log would be the load balancer's IP address or the proxy's IP address. If you know load balancers, you probably know that most of them actually send the original client's IP address in a specific header called x forwarded for. So by logging that specific field, we can just have that information and keep it for our purposes. A similar situation is when we're dealing with web applications that don't provide enough information about what's going on. As you've probably seen, some web developers think the only thing they have to do is just show the word error on screen, and that's about it, and that doesn't give us a lot. So by logging those fields, we can actually have information about what was really going on under the hood. Another situation is sometimes we have clients that don't behave well. Ideally, all clients are great, but sometimes clients just send incorrect headers. Bad headers cause some confusion with the web applications, and that is a situation that now we can keep track of using those recordings. Also, in a configuration where we have multiple tiers, Like if we have an environment where we have a web server and a load balancer and then another server in front of it, and we just have to keep track of stuff that's going back and forth between them. Sometimes when we have multiple tiers like that, the only way to really know what's going on is to track stuff like maybe the client's source IP, source port, and that kind of connection. To make this happen, we had to make some radical changes to our design. This is a slide that represents our design, the classic design of logging. What would happen in that kind of situation is that a client talks to HTTP sys, which is the HTTP protocol stack in Windows, of course, and runs in kernel mode. HTTP.sys talks to our worker processes, the W3 WPs that run the sites. And after that transaction completes, HTTP.sys logs the data into the log files. The challenge here is that the HTTP sys just doesn't have access to all that information that we really want, so we had to make some changes. And this is how it looks now. We've introduced two new things here. One is the log SVC, our logging service, which is new, and ETW, which is not new, but it now is part of this equation. ETW, of course, is event tracing for Windows, which is part of the Windows operating system and is being used for a lot of things. So what happens now is that after the transaction completes between the client, HTTP.sys, and the worker process, our log service keeps track of things. And HTTP.sys, instead of logging stuff into the text files, it sends information into ETW. Our log service queries ETW to get that information. It learns of a request that's came in, and then it can talk directly to our worker process to collect additional information that is needed. Like I said, the request headers, response headers, server variables. And once that data isn't available, it logs it into the text files that are kind of similar to what we had before. What does it look like? Well, now in the IIS management interface, we have a new option that allows us, in addition to selecting the old fields, which you might be familiar with, like we can see above here, you can click Add Fields at the bottom, and then select from a drop-down of server variables, request headers, and response headers. Each of them populates a list of fields that we've pre-configured, those sources. And if you want, you can also type in your own in case you have an application or a system that generates a custom or a unique header to that thing. Once log files are created in that new format, you can see that we have some new files here that have the appended _x that suggests and indicates that this is a log file of the new format. It's basically the same format as before. It's just to have those additional fields that you have defined to be included on it. And now back to my colleague Ahmed to demonstrate how this actually looks like on a real server.
Okay, so hi again. So here I have 4 machines set up for you. These 4 machines are basically a client, which is my Hyper-V host in this case. And then I have 2 ARR machines, which will work as proxies, and our 2012 R2 logging machine. So how many of you are not familiar with ARR? Is anyone not familiar with ARR? Okay, awesome. So everyone knows what ARR is. So what I have is, I have this, my client machine, which has an IP of 10.10.10.10. And it basically, I'm going to send a request to the first ARR proxy, which has an IP of 15. And this ARR is pointing at the second ARR, which is this machine, which has an IP of 16, as you saw. And then this one is pointing at the actual server, which has the IP of 10.10.10.17. This is the R2 server. So here I have one site that I configured for logging. We actually have 2 sites. So this is the logging site I'm going to work with. And if I go here and log, this is the new UI that you saw in Erez's presentation. And right now, I don't have any special custom fields. I just have the old fields that always exist in IIS. So let's first send a request to this site from the client here. Logging site. So it's going to go through ARR and it starts. And now the site is started. I'm going to refresh a while to create a few logs. And then let's go take a look. So if I go here, I'll see that I have 1 log created. And if you notice, it doesn't have the _x. And the reason is, this is the old logs. This is the HTTP sys logs. And because I didn't specify any new custom fields, we don't need to use the new logging. So we're going to continue using the old one. And if I open it, oh, it actually had this stuff. OK. If I open it, I'm going to have all my requests. And if my requests weren't here, because it doesn't flush all the time, you know, you usually go in Task Manager and do netsh http flush log buffer, sorry. And this should have all the flushed values now. So as you can see, it has the client IP, but in this case, the client IP is the last ARR machine, which is 16, because my real client IP is 10, 10, 10, 10. So as we said, with this new feature, you can actually log, for example, x404. So how would you configure that? It's very easy. I'm going to remove the user agent because it's just very long. Makes reading the log harder. I'm going to add a field called x4worded4. And in this case, it's a request header. So I'm going to leave this as it is. And as you can see here, we have a drop-down list of all the default request headers. And if something doesn't exist here, like, for example, the x4worded4, you can always type in what you want. So x4worded4. OK, OK. And then hit apply. And now, let's go send some more requests. So I sent here a few requests. And I'm going to go here. And as you can see, a new file is created, now with the _x. And the reason we have two files, the reason we don't just aggregate everything in one file, is because two components of the system actually owns the different files. So the first file is owned by HTTP sys, and the second file is owned by us. Since we don't talk with them this way, we can't really ask HTTP sys to release the file before we take ownership of the file. So we figured it's much easier, much simpler to just create a new file for us that's specifically for the IS new enhanced logging, and leave this for the old logging. Now, if I go open this file, oh, OK, it's flushed. So I have here the new field, as you can see, the x4worded4, and I have it here logged. Now, this is my client IP, which is the first one in the x4worded4 and the remote port. And then I have the first ARR box, which is 15, and then the second ARR box, which is 16. So it's very easy to log x4worded4, for example. And as you can see here, it logged right away. But what if there is a buffer here, of course, and this buffer will flush every time it's full. And if you want to flush something, if you want to flush this buffer faster, we added a new field here called we had a new field setting. If you go into System Applications, then Sites, and then go to your site, and then go to the log file, you're going to have flush by entry count. And in this case, it's 0, so it means when the buffer is filled up. If you change it to 1, it's going to flush on every request. Of course, you should never configure this in 1 for a production machine, because it's going to kill the machine. But it's helpful for tracking. If you want to track in real time in a production machine, Ares has another. We have another feature for this. But this one is very helpful for developers if they just want to look at files or want to debug a certain issue. So this is very easy to log request headers now. But this is not the only interesting part. What's very interesting now is we can also log server variables. So that allows you to do a lot of interesting stuff. Let's see. For example, here I have a module, a custom module that we wrote for the demo that populates 3 server variables with 3 interesting informations about the process. So what do I have? I populate a server variable called total requests. Total requests, and it's a server variable, and total requests. I also populate and use another server variable called process uptime, and it's a server variable, and it's process _ uptime. And the third and final one is process private bytes. That's server variable, and it's process private bytes. So now, if I go and send some requests here from my client, and go take a look at the log file, I'm going to have my x4worded4 flag because I didn't remove it. And then I'm going to have the process count, in this case, the request count. In this case, this is the 48th request to come to this worker process. And the uptime, this process has been up for 5 minutes now, and the memory at this time. And as you can see, this is very helpful. You can aggregate any sort of value you want or any sort of information you want from the process to the log file, to the IIS log files. All you have to do is basically put this information in a server variable and then know the server variable name and go and log the server variable. So now I know, when I look at my logs, my IIS logs, I can see that at this time the process was consuming, for example, in this case, 35 megabytes of memory. If I have issues where my worker process suddenly starts consuming a lot of memory, I can go back to the logs and figure out at which time it started to consume that memory, which page was requested, who's the client, and what's the IP of the client if they were doing something malicious. I can also look at the process uptime to see how many times my process restarted during the day. I can look at the request count, and so on. And I'm sure you can think of a lot of interesting stuff that you might want to collect about the process and aggregate these information to the IIS logs. One last comment I want to comment about this. If you notice, the request count here is jumping by 3, and you might be wondering about this. Well, the reason is because I'm sending a request, as you can see, to the root of the site, and this is creating a new subchild request that goes ahead and looks for the default document in the site. If I specify the default document here, which is default.aspx, and I send a request to the default document directly, and I go here, we're not going to have this jump by 3. We're going to have it actually, as you can see, it's default.aspx here, and it's going to be 109, 110, 111, 112, 113. And the process uptime again, and the private memory. So so the question is all the data from the other file in this as well? Do you mean, like, no, okay, so, no, so the question is, are they simultaneously being written? So no, once we start writing in the new mode, we stop the old one. So this one will only have the requests that were sent before I enabled the new custom logging. And once you enable the custom logging, we're going to continue to leave this file and start writing in the new file. So you won't have duplicate entries. There's only one entry for every request. OK, so this is my logging demo. I'm going to switch back to Error's presentation. And,
thanks, Ahmed. That was great. And another feature we've just added with ETW, with the logging, is ETW events. This is, again, something that a lot of customers have asked for. As you know, we have millions of users, and I've spoken to each and every one of them, and that's one of the things they wanted. The scenario we're talking about is real-time logging and custom handling of these logs. The challenge that we have with this kind of situation, and if you work with IIS logs, you probably know this, the text logs do take time to flush because we have this buffer, and even though we can set it to a lower number, this is not very recommended for a production environment. And also, if you try to work with these files, you can't really process them in real time. I mean, if you open the text files, they contain requests that already happened, and if you have new requests coming in, you have to reopen the files again to be able to see what's going on. So customers asked for this, and now we can use ETW to make things a little better. To remind you, the design we made to logging, this is the same slide as before, and we now have the log service that we have, and http.sys logs the stuff into ETW, the ETW provider in Windows, instead of going directly to the files. And just like we query ETW as part of log SVC, so can you. How does this look like? This is a new option in the IIS UI, where you have this selection. By default, it sets to the log files only, and if you set it to log ETW or both, that's where the magic starts to happen. Let's see how this looks like on a real server.
No, it's
yeah, doesn't work.
Oh,
there it is. Okay. By the way, just as an FYI, this is actually a virtual machine that I'm running on Azure websites. Azure allows you to upload your custom VHD file, and that can run any operating system. I'm running Windows 2012 R2, one of our intermediate builds. But if you want to run Windows 3.11 on on the cloud, you can just upload your own file. And if you're interested, there's a guide on my blog on how to do that. So what we do here is basically I just launch the IIS Management Console. I go into the logging settings right here at the bottom, and I enable both log files and ETW, hit apply, and now this takes effect. Now, as soon as I connect to the site and starts request, the stuff is going to go into ETW, and we can query it directly. There's a new tool by Microsoft, which some of you might have heard about it. It's called Message Analyzer. It's currently in beta 3, and it's going to be coming out pretty soon. This is a special tool that it's kind of like an upgrade to Network Monitor. It does Network Monitor, but also allows you to query ETW directly. So what I do is go to Capture Trace. I type in the name of the provider we have, which is IIS Logging, like this. Click on it. The tool loads the provider, and we click Start. And now this collects data in real time. So if I open my browser and connect to the site, I have a local site configured with not a lot, but as it opens the site, I refresh it a couple of times. As you can see, the stuff comes in real time. And when you click on one of these settings, one of the items, it will show you all the fields that we typically collect within the log. So you see the IP, the GET request, the URL. Here we are loading the actual fav icon. Here we have the request for the image that I'm showing on screen. And because we have this information right here, we can filter and parse it out in real time to see what's going on. So if you have a server that's accepting 20,000 requests a second, you can do a filter here and just show a few of them. For example, we have a quick filter here that allows us to define a specific time set. So we just drag it like this, and there we can filter out just a specific time frame within the log. The same thing if we want to just look for stuff that is in the files. I can use something like this, contains tiles. That's the name of the image file, and it's just going to show me those two specific requests that call for that image file. If, for example, we're troubleshooting an Exchange server that publishes ActiveSync, and we want to look for a specific, say, an iPhone or iPad device that's request might be coming in, we can just type in the contains with that device's ID or device name, and that will show us only requests coming in from that device, weeded out from all the thousands or hundreds of requests we have coming in at any single point in time. So this is really useful. Message Analyzer is a public tool. It's available for download right now in this beta 3 version, and we have a new one coming out towards the end of the month, and hopefully a final version a little while later. And that's a great way to just show this up. I'm sorry, what was the question? The tool? You mean how compatible the tool is? So the question was, how is the Message Analyzer compatible with all versions? The tool itself runs on any platform in Windows, so it can do its work with other providers, not just IIS, and do need capturing like this in real time. We find it easier to use than Network Monitor, but of course it's your decision whether to use it. But you can definitely use it on any platform. Of course, IIS's logging is part of the new version of Windows 2012 R2, so that is not available in other versions of Windows at this point. And let's go back to the presentation and talk about some more stuff. So let's summarize. What we've seen today is how we have improved IIS by making it more scalable by allowing dynamic site activation and idle process page out. We've also shown how we can have better manageability. Go on. Better manageability with logging enhancements and ETW logging. We had related sessions yesterday by Ryan Jones talking about websites for Windows Server, which are part of Windows Azure Pack and Windows Azure websites. The Azure website was right now according to this one, so you can catch the recording of it later on, as well as Ryan Jones's recording. You might be also interested in having these sessions, which will be going on as part of TechEd Europe in Madrid. If you're going to there, you might want to catch one of these sessions. You are welcome to visit my blog and read some more information about these new features we're coming out, as well as some guides and information. The WFetch tool that Ahmed was demonstrating earlier is available for download in this address here. The Windows Performance Analyzer, which Ahmed was using, is also available to download. And the Message Analyzer's blog contains links to the download and the later versions later on. In addition, there's these track resources, which we recommend that you visit to see what else is available with Windows Server R2. We have additional resources for TechEd, Channel 9, Learning, MSDN, and TechNet, of course, available at your service. And please don't forget to complete an evaluation of this session and be eligible to win one of these prizes. To participate in this evaluation, all you got to do is scan this barcode right here and evaluate. Thanks, everybody, for coming today. Appreciate your time, and we hope you like the new features. And if you have any kind of questions for us, this is a great time to have them. We'll stick around here some more and out in the hall later as well to answer any questions you might have. Thank you very much.